Hello, I'm Michael Carey, and this is Group 4, Integration and System Testing. So, what is integration testing? Well, integration testing is where you combine units or components together and seek to expose any issues or errors that might exist between those particular components. Another thing, all integration tests should pass before moving on to system tests. And the reason why is that integration tests should also be performed on live systems, such as a stage or test environment where you're testing email and database connectivity and maybe other API services. So you need to have those systems live and functional to validate it. And lastly, integration testing is performed between unit tests and system tests. Now, what is system testing? Well, system testing, there's various different ways of system testing. There's functional testing and also non-functional testing. So that could be regression, usability, and stress testing as examples of functional type testing. System tests occur after the integration tests and before acceptance testing. It is essentially validating the end-to-end product behavior and seeing if the system is functioning based on the specifications from the designer. Additionally, some certain percentage of those tests should pass. I recommend having 100% of your priority 1 and priority 2 features pass, and then you can work it out with the product owner with something less than 100% passing. So to kind of put it in full context, integration and system testing land in between unit testing and acceptance testing. And so the three go in order. So you want all of your unit tests to pass in 100% of integration tests. And then the majority of your system testing, well, they should all pass essentially as you move on to then finally doing acceptance testing. So here is an example of what a functional system test might look like. So in this particular example, it is launching a web page, pulling up a few things, and then automating that process through computer code to validate the functionality or content on that page. So that one was validating that an image was there. And so it'll continue to do that, check various different functional behaviors and features. So as you continue on here, we can jump forward. So this here is an example of doing API system testing. So you're testing the functionality of the various different endpoints one at a time, making sure that the endpoint is behaving the way that you're expecting it to. And so in this particular case, this is what is called verb validation, validating that the verb functionality, such as a get, put, or post, is working as expected from a designer's perspective and viewpoint. So again, this is system testing in a general quick nutshell, and we look forward to sharing more with you on the other presentations.
Okay, now let's talk about the upsides of integration testing. When a system is being developed as a set of modules, the logic that is implemented by one developer may be quite different than that of another developer. Thus, it becomes important to check that the logic that has been implemented is as per the specifications in the SRS. This testing makes sure that the integrated modules work properly. Integration testing can also be started once the modules are available. They do not require other modules to be completed before the testing can be done. Stubs and drivers can be used as alternatives to modules. Modules may interact with third-party tools, such as APIs. These also need to be tested so that the expected results and responses that are generated are as expected. Integration testing allows for developers and testers to choose the implementation approach that suits the needs of the application. There's three main ways. The bottom-up approach is the most common approach, as it is best suited for object-oriented methodologies. In this approach, the testing starts at the lowest module and works its way towards the upper modules in the application. This continues until the whole application has been tested as a single unit. The top-down approach, as its name implies, is performed in the opposite order. Here, only the top module is tested in isolation. After that, the lower modules are integrated one by one. This approach is helpful when many of the modules have been stubbed and developers want to test the top module. The Big Bang approach does not integrate each module one by one. It implements all modules at the same time. This approach typically should be avoided. However, for small applications, it may be acceptable. Now that all of the integration testing has been complete, we can take a look at the upsides of system testing. System testing is considered to be an end-to-end test, in which it includes verifying the interactions between all components to ensure that the system works as expected. This type of testing is typically done in an environment that is similar to or emulates the production environment. This allows for the stakeholders to gather usability requirements and evaluate user reactions. The result of both the end-to-end test and the evaluation by the stakeholders is reduced post-deployment troubleshooting and support.
And now to talk about some different integration testing downsides. For one, fault localization is very difficult. Since during integration testing you're combining multiple components, 2 or more, and to ensure they work together properly, it can be very difficult to find any bugs that may arise because you don't have one specific component you're looking at. You have multiples as well as in between the different components to look at for where the bug could have originated from. This can result in a lot of missed out time during project testing. Also, since all of the modules in that integration test are all tested together at once, you can't really prioritize one component over another. They're all supposed to be working together, and where you may have an application where one component or feature is vital to the application working 100%, you want to ensure specifically that that component or feature is working. With integration testing, you can't really focus on it. Instead, you plug it in with other components and features in order to make sure they all work as a whole, rather than that component working specifically. Now, system testing downsides, on the other hand, are actually very similar to integration testing downsides, but on a much larger scale. For one, when you're system testing, you're testing the entire application product as a whole. So when you're going to test, you need to create an entire framework for what kind of test cases you're going to be running, how you're going to be testing the entire application as a whole. And this framework can take a lot of time to build and look over and ready and prepare. Also, much like integration testing, the localization of bugs is very difficult, especially when you're testing the entire system as a whole. You're not just testing a couple of components like with integration testing. In this case, it's the entire application. So you get a little bug stuck somewhere in the application, you're going to have to search through the whole thing in order to find it. And that can be very time consuming. So overall, system testing, yes, it can give you a good outlook on how the application will actually deploy in the end. However, if you do run into bugs, it can take a lot of time away from your project.
Any software of sufficient complexity to need modularization should go through some level of integration testing. So when modules begin to appear, you should start thinking about integration testing. Looking at the times that integration testing should be used and its purpose, it is recommended that you wait until the time that a piece of software has some modules that are required to interact. As an example, you wouldn't need integration testing if you only had your UI and database built, as they will likely not be talking directly to one another, and so integration testing would be meaningless. A second point of recommendation of integration testing is that test writers have a firm understanding of the modules themselves. Unfamiliarity can lead to the creation of false positive or false negative tests, or tests that fail to actually test the integration of modules. If you don't know the expected outcome of a transaction between modules, you can't write tests for them. Finally, it is important that integration testing doesn't fall into the trap of becoming more unit testing, and focuses firmly on testing the communication and reliability of the connection between modules instead of the actual internals of a module. System testing really requires a system before such tests can begin. Before this point, it is impossible to really even do system testing. It is recommended that for good system testing, you need a complete build of your system that is stable enough to go through testing. If too many errors occur at other levels of testing, unit and integration, it's unlikely that you will get any good usable data from system testing at this point. It is recommended that system testing continue through the lifespan of a piece of software, especially as new capabilities are added. It is important that a system test is used to verify the stability and continued usability of both old capabilities and new capabilities of software. Finally, system testing is the primary location where environment testing begins. Testing every possible environment and every possible condition is an impossible task. It is therefore important to focus your resources and time on the issues that will cause the most friction. Things like data integrity or a main button not working are far more important than a hover color transition. Focus your system testing on what matters first, and then work down into fixing the minor things.